Greetings, humans. We're going to be talking about volume, specifically with prisms and cylinders. And volume is the amount of space an object occupies. And this volume is measured in cubic units. So cubic meaning there's 3 dimensions. Instead of just 2 dimensions, we're seeing how much 3-dimensional space, so adding the element of depth, an object will take up. So let's go right away and do some examples here. So these ideas are pretty self-explanatory. Instead of looking at the basic ideas of area, which is what's being displayed here in the figure, the second figure, you see 4 times 2, and you see the area is 8, of course. But when we add this extra dimension of depth, then we're talking about area, because that begins to take up space. So all we really have to do to figure out the volume of a prism is talk about the area of the base, which is this big B, the area of the base, and multiply that by the height of the object. So in the first case, you've got 4 times 2 is the base for 8, and multiplying 3, which is the height. And you can see that it's 24 units cubed for the first rectangular prism above. Very easy. Okay, let's pretend like this is a nicely drawn triangular prism. And again, it doesn't matter, triangular, it doesn't matter whether the prism is a rectangle or a triangle, because you're looking at the base, what I'm shading in red here, and you're extending that up the height to figure out what the volume is. So for this shape, it's still going to be the big base, the base multiplying the height. To find a base of a triangle, a triangular shape, it's 1/2 the base of the triangle times the height, and you're looking to multiply that by the height of the entire 3-dimensional shape, the H in red up here. If this object was labeled with a 6, say, and an 8, and let's pretend that this met at 90 degrees down here, the flat part or the bottom, the big base. So this constitutes the height of the triangle, and this constitutes the base. So it looks like 6 times 8, and 1/2 of that. If you multiply that by the height, let's assume that it's 7 for our purposes. If you multiply 7 there, that's going to get you the volume. I don't know what that answer is, but it doesn't really matter. It's the idea that counts. Here's a pretty 3-dimensional object. Let's pretend that this measure is 12, this measure is 18, and this measure is 6. Go ahead and find the volume of this. Okay, and now we're moving on to cylinders. Notice that this diagram shows the same thinking that we had when we had rectangular or triangular prisms. You're looking at the area initially of the shape and just allowing that area to take up a 3rd dimension of depth. So you're going to find the base area here, which makes sense, circular, pi r squared, and then you're adding the 3rd dimension of height. That's your area. That's your volume formula. It's that easy. So let's take it to an example. Here we go. If we were asked to find the volume of this cylinder, we can go and figure out pi r squared. That's a circle, but we've got to add the element of height for the 3rd dimension. That's to find our volume. Be careful here, the only thing tricky is to find out that the radius is 4 because the diameter is labeled as 8. When you square that, if you multiply pi and the height, you're going to be in good shape. So you've got 16 times 12, whatever that is, multiply that by 3.14, and you will have the volume. If this is centimeters, then we're talking about centimeters cubed, or cubic centimeters. Okay, easy enough. You try one. I'm adding a degree of difficulty because I think you can handle it. The volume of this here object, this cylinder, is 400 centimeters cubed, or cubic centimeters. The radius is, let's go for a nice even 10. Go ahead and find the height. What is the height given that the radius is 10 and the volume is 400 cubic centimeters? Good luck, bring that tomorrow, and I'll give you a special prize if you get it right. Ooh, incentive. Good night.